This is lesson 47 for 8th grade, and today we're talking more about functions, in particular graphing functions. We've been working with lines lately, talking about slope, and we haven't defined what a function is, but we're going to revisit that today. And we're going to get a little bit more in depth with some of these things that are involved with the functions. So up until this point we have been graphing the functions, but we've only really talked about slope. There are other parts about the functions that we want to talk about now, and that's kind of the meaning behind what a function might mean. Okay? So recall that a function is a rule that pairs one output number with each input number. The following picture of a function machine and two buckets illustrates the relationship between the domain and the range, the set of outputs of a function. Okay. So domain and range are the two new things that we're going to talk about. Remember when we were graphing before, we had our x, y's, and we'd put some numbers in for x, and then we'd get y's, some answers for y. So depending on whatever x was, we'd get a different output for y. So these were our inputs, x's, outputs were the y's. So basically, just instead of calling it inputs and outputs, we call this the domain, and this is the range. So fancy names for two things that we already know. Okay, and we'll get into what a function can be. Normally we're going to see it as an equation, but we're going to see graphs, tables, and sometimes even descriptions. But anyway, just remember that whatever x you put in is going to output a certain y value. And what we're going to be able to do is look at equations or tables or a description or a graph, and we'll be able to describe what that graph is kind of talking about. We'll be able to see, describe what the domain is, and we'll be able to describe what the range is. And on top of that, or on top of what we already know, like finding the slope and things like that. So some fancy terms, but it's things that we've already seen. Okay? Okay. Oops, sorry. So a good example, a checkout scanner at a store is a real-world example of a function machine. The input is the product code the scanner reads, and the domain is the set of codes programmed for the scanner. The output is the price the register record records for that product code, and the range is the set of prices of the coded items. So when you scan something at a store, or when a clerk does that for you, it reads a certain number, and that certain number is attached, or has a price attached to it. So the program number would be our domain, the input, and then our output is the price that it records for that number. Okay? So for each coded item there is only one price. Different coded items may have the same price, but each coded item has only one price. Alright? And it says functions may be expressed with descriptions, equations, tables, or graphs. The sign in example 1 is an example of a description for a function that pairs the number of hours parked and the number of dollars charged for parking. And that's this example right here. Okay? Alright, so this sign describes a function, a rule that relates hours parked to dollars charged. So what is the domain of this function? Well, the domain is the input. Okay? And B is going to ask for the range, and that's the output. Okay? So what is the input? Well, you have to go there and park first, so the domain should be the hours. Okay? So depending on how many hours you work, depending on how many hours you park, that's going to determine what price you pay. Okay? For instance, if we started, well, here, let's bring this up. Oops. Oh, I guess I didn't put that in there. Anyway, but yeah, like I said, depending on how many hours you park, that would be our domain. it's going to give us a certain price, and that's our output there. Okay. And if we want to talk specifically, let's see what can happen here. $1 for the first hour, $2 for each additional hour or part thereof, $15 maximum. Okay. So looks like if we were to start making a little table here, lot open 6 a.m. to 10 p.m. and no overnight parking. Okay, so you can't park overnight, it's open from 6 to 10. And we want to look and see. Okay, 6 to 10 then. So our input then is our hours, we said. So we want to look from 6 to 10, how many hours is there from 6 to 10? Well, from 6 a.m. to 12 p.m. there are 6 hours. And then from 12 p.m. to 10 p.m. there are 10 hours. So 16 hours, or 0 to 16, would be our domain. So that's the domain, how many inputs you can have, the hours there. Open from anywhere from 0 hours to 16 hours. Okay. Now what is the range? Well, looks like for the first hour, it's $1. Okay. So now we're looking at prices, and then it's $2 for each additional hour thereafter. Okay. $15 max. So we'd be looking at $1 for the first hour. And any hour after that, and there's a $15 maximum. So a $2 charge for every hour after. So let's say you're there for 2 hours, that's $3. Let's say you're there for another hour, that's $5. Okay? So basically every hour you're adding on $2. And it goes up to 15, and you can't go over 15. So for our range, we would say the odd numbers from $1 to $15. That would be our range. Odd numbers from $1 to 15. $1 to $15. Okay. So if we were actually to graph this thing, it would look kind of weird. This one takes a little while. I like it better when they give us just an equation rather than a description, but we can graph it. So range is always your output or your y's. So here we're going to have dollar amounts. Here is going to be time and hours. Alright. So let's set this thing up as, okay. I want to make sure we set it up the same way that they do. Hours, time, good. So we're okay. Let's see if they go up. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, we were setting it up the right way. And this one went up to 15. That's the most you can get. 5, 10, 15. Alright, so the most you can get is $15. Okay, so for your first hour, that's from 0 hours to 1 hour. You can be charged $1. Okay, but once that hour is up, we're going to leave an open circle here, because once that hour is up and you've been there for 2 hours, you get charged $3. Oh wait, sorry. Okay, so this is going to be kind of a weird looking function. So from 1 hour to 2 hours, it's $3. And from, so this is 1, 2, 3, 4. And if you're there for 3 hours, it's $5. And that's from 3 to 4. 4 hours, that gets you to $7. I keep writing it backwards. Alright. Now the reason I'm putting circles here is because from 1 to 2 hours, if you're there for 2 hours, once you hit 2 hours, it's no longer $3 anymore, it's $5. And once you're there for 4 hours, it's no longer $5, it's $7. So it keeps going on like this. Eventually you get to a point where you're here, and then for the remainder of your time, it's $15, because that's the most you can pay. Okay, that one's kind of funky, and it takes a little bit longer. We'll go through that one again tomorrow for sure, but we want to take a look at one that's a little more mathematical. Okay, so we're going to take the perimeter of a square function, and we're going to consider, well, you know, a square has all the same sides, so if we want to find the perimeter of it, we've dealt with this function before. Whatever side your square is, let's say it's a 2 by 2 by 2 by 2 square, it'd be 4 times 2 would be 8, and that would give you your perimeter, or you could just add up all your sides. But if you multiply one side by 4, that gets you your perimeter. So, we're going to look at the domain. I'm going to say S and P for when we graph it later. But basically I'm doing that is because this is your input. Whatever side your square is going to determine what your perimeter is. So what is the domain? What things could S be? What are our different sides? Well, let's think about this. If we have a square, we can't have any negative sides. So we're going to say that S, or the side of a square, could be any positive real number. So all positive real numbers. That's what we would say there. Now what is the range? Well, if we're going to put in any positive real number, we could output any positive real number. So once again, it should be all positive real numbers. And that should make sense because we can't have a negative side, which means we can't have a negative perimeter. Create a table for some function pairs. Let's do that. Let's choose easy ones. Let's say our side is 0. Perimeter is going to be 0. Let's say our side is 1. Our perimeter would be 1 times 4, 4. Let's say it's 2. 4 times 2 is 8. Okay? Now if we graph that real quick, and we've graphed this before, we'll go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Alright, this would be perimeter, this would be side length, okay? If it's 0, perimeter is 0. If the side length is 1, it's a perimeter of 4. If the side length is 2, you get a perimeter of 8. Now we could go ahead and calculate the slope of this thing, because we've learned how to do that now. But that would be our graph. It's a linear graph, and we could calculate the slope of it. And in fact, it happens to be a slope of 4. Okay. Now this type of graph we should recognize. I'm going to bring up one more point, and then we're going to cover this more tomorrow, and probably the next day, because this is an important topic. Okay? Let me check my time quickly. Okay. Just the last thing here that we want to point out, that last graph that we saw, we would call a continuous function. It has no gaps like that first one that we did, that kind of confusing one that we did with the parking ramp. That one had gaps. We called that a step graph. You don't see those too often, but this function happened to be continuous because it would go on in one direction forever, positive direction. And the important features were, first, that graph began at the origin. Remember, it looked like that kinda. We had a straight line from the origin. And all points in the graph are aligned, or basically it formed a straight line. It was a linear graph. Together, these two features indicate that the function is a direct proportion. And we will be studying direct proportions in many lessons in this book. Basically what you can do is take any two pairs, let's say we took, because we did what, S and T, we had 0, 0, we're not going to count that one though, because that's just this point right here. 1 and 4, and 2 and 8. You can take any two pairs, they took 2 and 8, and they should be in proportion with each other. So if I do 2 over 8, it should equal 1 over 4. Is that true? Well, if I reduce this, if I divide by 2, I get 1. If I divide by 2, I get 4. Yes, that's true. But basically, we've seen this before. A straight line, or a linear line, that protrudes from the origin is going to be proportional. Alright, we will cover this more tomorrow, and we'll tackle some more of those tricky ones like the parking lot one, but most importantly we're going to look at these continuous ones because this is more of what we'll see in algebra.